Index number. Okay. So now, indexes, I said last one in last session on Saturday, how it was working means it's a book index page. So in a textbook, okay, index pages are how it was working. Same as your index database index is also working just like a index page in your textbook. So by using index page, how we can retrieval, how we can access a specific or particular topic, okay, from your textbook fast and quickly, same as a specific row when you want data from your table. So I can retrieve the data with the fast and or quickly. So in that cases, indexes will be, okay, it was very key role will play when data retrieval process. Okay, then how it was working and how many types of indexes, what are those, that all we will discuss. And first we will see some definitions of indexes right now. So it is a database object. It is a database object, so which is used to retrieve or to retrieval a specific row from a table fastly. Database, okay, index object will work just like a book index page in textbooks. Okay, so by using book index page, we can access a specific topic from a textbook fastly, same as by using database index. By using database index, we can access a specific row from a table fastly. Okay. Next, by using indexes, we can reduce searching time and improve the performance of database. Okay, so by using indexes, what is the advantage? Okay, we can reduce searching time. Okay, now so searching time will be reduces and improve the performance of database. Okay, right. And the next one, indexes how we can create it into database tables means. So index object is created a specific or particular row or rows. So that means, are you created any particular specific row? Otherwise, you created on more than one column. Okay, you can create. For example, suppose this is one of my table. So you have some columns here. Okay, suppose X, Y, and Z is columns. Now what I'm going to do, I'm creating my index object. Okay, I1. So my index I1, on which column I created here? X column. So the most important point here, what now? On which column are you created your index object? Okay, so that column is called as what now? Key indexed column we called. Okay, on which column are you created your index object? That is called as a key indexed column. That column is called as a key indexed column. And when you want to retrieve, okay, when you want to retrieve data from this table, so based on X column conditionally, if you retrieval data, then only indexes can be activated. So on which column you created index, based on that column data only, you need to retrieve. You need to fetch your data. Suppose here my index was created X, but I am retrieving data from this table based on Y column or Z column. That means how I'm going to writing my query. I'm writing my query. Select a star from so-and-so table where Y is equals to some value. Some value if I given. Okay, Y is equals to some value. Then what it was say here, whatever the condition I was given under where class, this conditional column, okay, is it a indexed column or non-indexed column? Non-indexed column. So if it is a non-indexed column, then indexes are not working. Indexes will never work. And non-indexed column, if you use here, then your indexes mechanisms are not performing. Okay, now that is one thing. That's why what we want to do, compulsory, it's a must be. There is no other chance. Okay, mandatory. So once you created index object on particular column, on which column the indexes are created, compulsory that column should be take in your where class. Compulsory. Okay, now so which column is my indexed column? That column only should use in my where class. Then only indexes are activated. Indexes are activated on the table and fastly retrieving your data. Understand now? So on which column we created index object, that column is called as a indexed key column. And that indexed key column should use under where class condition while retrieving. Understand now? While retrieving time, compulsory indexed column only should be there under where class. Other than indexed column, if you given, then indexes are not activated. If indexes are not activated, then what it was happen? Your entire table data will be searching. When data entire table will be searching means automatically time consuming, performance degrade, retrieving data slow. Got it my point now? That point should be remembered. So that means what I want to say, on which column we created an index object. That column is called as indexed key column, and this indexed key column only, and this indexed key column only use under where clause. Under where clause condition. Then only indexes are okay working. Otherwise indexes are not working. Okay, right. So these are the some points here. Observe. But here, can you observe? So when data retrieval process, that means, suppose, sir, if I'm not creating any indexes on my table, okay, now, if you are not creating any indexes on your table, then what it was happen? Okay, then how the data can be retrieved? Here, observe. Suppose one of is of table, okay. So in this table, okay, if you need to retrieve a specific row or rows data, then what it was happen, for example, I just go to write my request is EMP where salary is equals to 3,000 rupees. So 3,000 is there. Huh? Okay, fine. The salary is equals to 3,000 rupees. Okay, that is my request. So what it was happened here, this whatever the request we are sending now, this request, okay, will go to your Oracle server. Oracle server, what it will go first, which table it is? EMP. So it was going to your database memory, first EMP table. On which column conditional basis are you retrieving your data? Which column? Salary column. So it will be go to salary column here. And first, the server, what it will do on this column, okay, user is created any index object or not. First, checking. Suppose on this column, index object was not created by programmer, okay, then what it was happen? It will be follow the default searching mechanism that is called as a table scan. Which mechanism here? Table scan mechanism. So when the table scan means what now? Default scanning mechanism. It's a default. So first it will go to as per your request. First go to table, go to column. On the column, index is there or not there, checking. If it is not there, then by default mechanism will be follow for your searching data purpose. What is your default mechanism? Table scan mechanism. What is the table scan? Table scan is nothing but what now? Each and every value we need to compare with our condition. What is our condition? Salary is equals to 3,000 is our condition. Yes or no? Then every value is going to checking. So 800. So 800 is equals to 3,000. 800 is equals to 3,000. Condition true or false? False. 1600 is equals to 3000. False. 1250 is equals to 3000. False. 2975 is equals to 3000. False. 1250. False. 2850. False. 2450. False. 3000. True. It is a true. So immediately this entire row will take to fetching from your table. Okay, sending to client application. So after so many people, what they think, my required data was found here, so that my server will stop searching mechanism. So many people thinking what now? Server will stop searching mechanism. Because of reason, my required data was found and I was taken. Then why should I want to go remaining rows need to search? So this kind of confusion doubt is there. But remember, tables can, the nature is what now? Even though your record is found and you take it, okay, but still what it was happen, your searching will not stop here. The searching will be continue up to end of the table. That means after finding your required data, but still your searching will be continued, will be continue. So again, continue next what now? 5000. So 5000 is equals to 3000. Condition true or false? False. Next 1500 false. 11 false. 950 false. And next 3000. Condition true. Then this record is also fetching from your table. And after that, next record also searching 1300. 1300 is equals to 3000. Condition true or false? False. Suppose just remember, in the first attempt only, your searching will be stopped here itself. Then tell me, how many employees data can I see? Only one. But your 3000 employees, how many people? Two. So that means if I stop my searching here itself, then the next employee 3000 salary details are I'm not getting. That's why even though your data was found, okay, for example, your data is found. If I'm writing my query, somebody is asking doubt, sir, can I write what happened, sir? Select a star from EMP where sal is equals to 800. Okay, now? Then again, same thing. Suppose you are not created any index on this column. Again, what it will be performed here? Table scan. Table scan, how it was performed? Each and every row. Now check it out. 800. 800 is equals to 800. Condition true. Condition true. So that means what I want to do, condition true at which level? First row only. This is called the best case. This is called the best case. In the first row only, my required data was there and immediately I pick that row. But it's not like that. Your record first only it was found now. Then it doesn't go to searching remaining 13 rows. That's not happened. The remaining 13 rows also searching. Even though your required data was there in the best case, in the number one position, and the data will be taken. But what it means, data will be taken means your searching will not stop itself here. It will be continue up to end of the. Suppose your table is having a 1 lakh row, and your best case is your required data was there in the first level only. That means the remaining rows are searching or not searching? Searching. That is the problem of what now? Table scan. That is the problem of what now? Table scan. Okay. And that problem, to avoiding purpose, the people was introducing one of the new technique. The new technique is called as a index scan. The new technique is called as what now? Index scan. Understand now? So that means here how many types of scanning mechanisms? 2 types. One is a table, one is index. Right down below. Oracle supporting the following 2 types of searching mechanisms. Those are First one is called as your table scan. Second one is called as your index scan. So what is table scan? So table scan, okay, in this mechanism, what it was happening, you can see. In this method, Oracle server is searching the entire table for required data. Okay, no? So this is table scan mechanism. In this method, Oracle server is searching the entire table for required data. Example, what, sir? So my example is, I was written select a star from EMP where salary is equals to 3,000 rupees. Then what it was happened when you are sending like this, okay? So whatever your salary column data is there, so it was going to be searching here. Okay, so these 14 records are searching with which class condition, where salary is equals to 3,000. So now we can see the 14 rows are going to be searched here with your condition, where salary is equals to 3,000. Not only one, total 14 values are checking. So that means here, how many rows or how many values are comparing here? Come on, comparing 14 rows. Okay, here. So comparing 14 rows, that means 14 times. Data comparison is how many times? 14 times. Okay, 14 comparisons or 14 times it will be comparing your data. So each and every value will be compared, like 14 rows, 14 times, 100 rows, 100 times. Okay, na? 1 lakh means 1 lakh times. Okay, na? It will be checking here. Each and every row will be checked out. Okay, na? Now, so now just imagine. So each row, for each row, okay, for each row purpose, your Oracle server will take 1 second of time. Just imagine, just I'm telling imagination, assume that. Assume for each row purpose 1 second of time. If it was take, okay, then 14 rows into 1 second is equals to how much time it will take? 14 seconds of time it will be take. If you logically, if you assume like this, then you can understand the concept. So 14 into 1, each row 1 second, so that 14 rows into 1, 14 seconds. So in this 14 seconds of time, your server was given which value? Where salary is equals to 3,000 people data was found and sending to client for that purpose. How much time it will taken? 14 seconds of time was taken to finding your data, sending to your client application. So now my question is what now? Is there any other alternative method is there? Is there any other alternative method is there? The same data will be retrieval from the table less than 14 seconds. Yes or no? For example, you want to go from your source location to, for example, this is a classroom. So in this, so many people coming from their hostels. So if you want to go your hostel, there are 2 to 3 ways are there. Routes are there, 2 to 3. From this classroom, once class is over and you want to go your hostel room, then in these 3 routes, which route are you selected? Which is shortest route. Yes or no? Suppose one route, if I choose first route, it will take a 10 minutes of time to reach your hostel room. Second route, it will take a 5 minutes of time. Third route, it will take a 15 minutes of time. Which route are you selected? Second route. Got it my point now? Same as here 14 rows are comparing. Comparing how many rows? 14 rows are comparing. So 14 rows comparing means each comparison of row data, your server internally taking second time. Server internally taking 1 second of time. So comparison, each comparison of raw data, server will taking 1 second of time. Like this, here this data comparison 1 second, comparison 1 second, comparison 1 second. Comparison means what now? This condition comparing with the whatever the value was given here. Okay, like all are 1 second. Then finally you got it your answer within 14 seconds. Got it my point now? So now our next requirement is what now? Why should I want to wait for 14 seconds here? Is there any method was there that to retrieval the same information from the same table out of 14 rows, maybe it will be less than to 14 seconds. Suppose I have one method. Which method? Index method. If index method retrieving the same information, same data from same table, from same number of rows, it will take a 3 seconds of time. And table scan will take a 14 seconds of time. Then tell me, database programmer will prefer which method? Index method. Because of reason, how much difference? Of time we are saving now. Saving or not? That means performance is high performance or low performance? High performance. Okay, that is what advantage of a index. So now this is what now? Table scan, right? No? And like you can give each comparison will go like this. So every value is going to be comparing. Like 14 times your server will go to 14 times to your table, because each time it will be check only one row data value. Okay, now only one row checking. So like this 14 times your server will go to your table, and each time it will go take one value and that comparing with your condition. So 14 comparisons and 14 times your server will go to table data. Okay, right. And now, so this is what a table scan mechanism it is. Okay, now. Okay, 14 times. Now let me see. But you have a question here. So how I know so on this column index is created or not? Okay, so there is one data dictionary we have here. The data dictionary name is called as user underscore ind underscore columns. So this is one of the data dictionary. Here you have an index name, table name, column name. So now I can come out and see my column underscore name, comma, index underscore name, okay, from user underscore ind underscore columns. Okay, now? So now where table underscore, so name is equals to, what is the table name? EMP. So now EMP, but what it was showing? So that means on my EMP table, do have any index objects? No. That means in my table, I have total 8, 1, 3, 6, 7, 8. Total 8 columns we have it. But out of 8 columns, there is a no indexed column. There is no indexed column. So that's why all are non-key index columns. Non-key indexes. So now these are all. So in that cases, now suppose you are writing your request. Select a star from EMP where salary is equals to 3000. Okay. Then what it was happened? Your required data we are fetching. But this data fetching purpose, what I'm saying here, internally, how many seconds of time? 14 seconds of time was taken by your Oracle. Now understand? Na? So now what I want to do? So now, no, sir, I don't want it. This lengthy process method. Let me go for, is there any shortcut method is there? Okay. So then the people was introduced another method that is called as what? Index scan method. So in this index scan method, let me come out and see. Okay, in this method, first write down, later I will explain to you. In this method, Oracle server is scanning. Okay, server is scanning based on an indexed column wise for required data. So here indexed column wise only data will be checking or searching, okay, for your required data. But here this index scans are created into, there are 2 ways the indexes can be created. Okay, na? So database index objects are created in 2 ways. Okay, na? The first way is called as automatically. First way is called as what now? Automatically. Indexes are created by system. Second one is called as here manually. Second one is called as what now? Manually. Here automatically, it means what now? These kind of indexes are called as a implicit indexes we called. The implicit means user defined or system defined. System defined. Next one is called as a explicit indexes. Okay, right. So in this first mechanism, I will show you automatically how to create indexes on your table column. Okay. Here observe. Automatically, that means system when it was created, your index object means here observe, when you created your table along with your primary key constant, and already we know what is primary key, what is foreign key, yes or no. Otherwise, when you created your table unique constant wise, in the two constants wise, if any table are you created, that means when you created a table, are you applied what now? Primary key, otherwise unique. In these two, any one you can apply. Then internally your system is going to be created index object. Okay, so primary key constant, are you applied on which column? Exactly on that column your index was created. But who will create it here? Internally system is created. Okay, user, I'm not created, I'm just applying primary key, that's it. But automatic indexes are created by system. And when you just apply unique, then automatic indexes are created, automatic system is created indexes. So that is called a automatic procedure or implicit mechanism. Okay, now write down. So what I want to say, when we created a table with the primary key or unique, with the primary key or unique constant, with primary key or unique constant, internally system is created, internal system is created a database index object. Internal system is created a database index object on that column, automatically on that column automatically. Okay, then how? Examples also I will show you. Observe. First of all, I will check in my database how many tables are there. Okay, fine. So now I'm creating one table, test number, okay, 41, and see carefully, employee ID. I'm just applying here primary key, that's it, and employee name. So when you apply here, your table is created. And after that, you want to see whether on this EID column, indexes are created or not. How I can see means, so have your data dictionary. Which data dictionary? User underscore IND underscore columns. So by using of this data dictionary, my table number, test number 41, and see your index is created. The column name is what now? EID. What is index name? sys underscore C007580. So can you remember at the time of constants, when you're working on constants, this key IDs are we discuss? Yes or no? So that constant key name is called as a index name also. That means already we knows this, but there I was not informed to you what is this. And there we are discussing like a constant name. That's it. But every constant key name is also index name also. Now it was confirmed here. Okay, now. So now here see on EID column, that means on which column you applied a primary key constant. On that primary key constant, your index name is created, and my index name is sys_c007580. Same as what next we are telling here, test number 42. Suppose serial number, and I'm going to apply here unique. And now I'm taking some salary number. So here also table created unique constant, but let me your index is created. Yes. So that means what you understand, when we created a table along with unique constant, okay, or else primary key constant. If any one constant you can use, then automatically this right down below. Now note point also below right down. If we want to view index name along with column name of a particular table, then we use a data dictionary. Dictionary is called as, then we use a data dictionary is called as user underscore ind underscore columns underscore columns.
Boarding in progress.
Okay, completed. Now we can see this is automatically system will take to create this indexes. But when manually, how to create it? Okay, now, so when we created an index object, when we created an index object on particular column of a table, then we called as explicit indexes. So here user can create two types of indexes. User can create two types of indexes. Okay, so what are those? First index is called as a B-tree index. And in this B-tree index only, okay, there are different formats and different ways we can create. First one is called as a simple index. Second one is called as composite index. Third one is called as unique index. Fourth one is called as your functional based index. Okay, and the second type of index is called as a bitmap index. So here manually our user explicitly they can create two types of indexes here, B-tree and bitmap. But in the B-tree, in the B-tree, we have a different formats. The B-tree indexes can be created. Okay, simple, composite, unique, and functional based. Okay, all right. Okay, so first I will explain to you the B-tree indexes, what is simple, and when we are what now and why we called as these many ways. Okay, let me see. My first one is called as your simple index. Now take siding simple index. So what is simple index here? Observe. And when we called my indexes are simple means when we created, okay, so when we created an index object based on a single column in a table. Okay, so then we called as a simple indexes. So simple means we are creating our index object only one single column in a table, and more than one column you can't. Here only one. Okay, and now how it is the syntax, because it is a explicit. No, explicit means user want to create. User how to create it by using of this syntax here. create index and my index name, okay, on table name of which column name. Table name of which column name. The column name should be passed here. And let me see, I'm going to take one example on this. Come back. First observe. So the previous requirement is what now? The same thing where salary is equals to 3,000. And whenever you want to retrieving some specific conditional data rows from my EMP table, what we said at that moment on my salary column, there is a no index. On salary column, there is no indexes. So that's why by default, it will be performing table scan, and table scan through this result will be displaying us. But internal mechanism, what I was explained, when there is a no index on a column, then each and every row value will be compared. Like how many rows? 14 rows. Then 14 seconds we assumed there. Okay. But the same scenario, after index is created on the salary column, then how many seconds or how many seconds of time it will be take now? Check it out. So now what I want to do on the table, now I want to create a index. So now I'm creating, don't write, first observe. Create index I1 on which table? EMP of which column? Salary column. Now tell me your index is created how many columns wise? How many columns wise? Single column wise. Which column? Salary column. So now index is created. After index is created, whether now index is created or not on this column means, again what I want to see, user underscore ind underscore columns, where test number, okay, instead of that, what is our table? EMP. Now we can see column name is, index name is I1. Clear? Now index is created. So now which type of index it is? Simple B-tree index. Which type of index? Simple B-tree index. But when you created a B-tree index on a single column, then it is called as simple B-tree indexes. Okay. But here, what internally it was happened, sir, when you created a indexes. Okay. Now, so whenever you created an index on particular column, on that column, or that means in that column, whatever the data was there, that complete column data, that means which column I created? Salary. In salary column, how many values are there? Those values are first, your system will arrange in which format? B-tree format. B-tree means binary tree format. So tree structure format, it will be arranging your data. Your data is not in a tabular format. Your particular column, on which column index is created, that column data was arranging by your system in which format? Tree structure format. Tree structure format means what now? First, tree starts from root. Root under what? Parents. Parents. Parents under children's. Children's. This is called as what? Tree structure format. Tree structure format. This is the format the data will be arranging first. But okay, sir, root level, parent level, child level. This is root level. Okay. But this root, how it will be started? From which value will take as a root? Because in my salary column, there are so many values are there. Yes or no? Yes or no? There are so many values are there. So then which value is a root, sir? Root means base, from where you want to start. So, but here so many values are there. Out of so many value, which value will take as a starting point? Yes or no? Root means what now? starting point. So which value is my starting point? Who will decide? How it was decide means, now which is starting 800, 1600, 1215, 2850, what it is, I don't know. But the route will be decided by your system based on user request. Based on which request? User request. So now user request is there. What is my request here? My request I'm sending to my server, select a star from EMP where. Suppose if I'm giving here where department number is equals to 10, if I'm giving, for example, then tell me department number 10's data, how to take? Index scanner, table scanner. Table scan. Why? Because on DEPT number, we are not created any index. Then by default, table scan. So that's why on which column are you created index? That column should give under where class. This is very, very important point to our interviews. Okay, na? Where salary is equals to 3000. So on which condition value was given here and which conditional value basis are you retrieving your data? Now what it was happened, this request will go to your system. That means server sending to whom? A system. The system, what it will do here? Based on this 3000, this is called a root value. The root value, how to decide, means that based on conditional value. So whatever the condition basis are you retrieving your data, that is your root. From that root, your system will arranging remaining values in the tree structure format. After arrangement was done by system, then later server will come to this index page and searching your required data where it is. Understand now? So that means carefully observe. Server is a customer. System is a publisher. Understand now? So for example, your books are there. Textbooks. In textbooks, index pages are created by who? Publisher. So who prepared this book? Those publishers are created index page and releasing in the market. That index page facility, who will use? Users. Okay, this is also same thing. System will create a binary tree structure. That tree structure, whatever system is created, that is called a index page. That index page, who will use here? Oracle server. So Oracle server is a users. Index page is a whatever you created, binary tree, whatever it is. Who will create it here? System. System is nothing but publisher. So publisher, system. B-tree index, index page. Users, server. Concept understand now? Otherwise, so many people confusing. Okay. So then what it was happened? First data is arranged. That means index page is creating now. So how index page is created? Let me come out and see. So when we are sending this request, based on this request, okay, below what it was saying, B-tree index is created. So first observe concept, later you can go to write. What is my condition? Sal is equals to 3000. Sal is equals to 3000 is called as a root value. So root value, I think you all of you know binary tree structure now. In your colleges, maximum computer background students, they know. Yes or no? So now here observe. Root value, okay, if it is less than, okay, the value which is less than to root, that will be stored at a left pointer side. LP, left pointer. And the root value when you compare, which is more than or equals to those values are keeping by your system in right pointer. In a right pointer. Got it my point now? So less than values are keeping left side, greater than or equals to values are keeping right side. Very simple point. LP, left pointer, right pointer. Let me come and check. So now your system will go to your table. I will call here. Select a star from EMP. In this EMP salary column, first what it will do, what is your highest salary? 5,000. So 5,000 will take. Compare with your root value. Right side or left side? Right side. Okay. Now I'm keeping in the right side. Same right side also. LP. That means it is called a parent level. Less than values are left side. My value 5,000. 5,000 above and equals to values are in the right side. Okay, now? So this is what we called as here parent. This is a root level. This is parent level. Okay. Next, what is the next highest salary? 3,000? Okay, 3,000. How many times? 2 times means how many rows? 2 rows. That means, can you tell me this Scott row ID and fraud row IDs? 2 rows are there. These 2 row IDs, is it the same or different? Different. Row IDs are permanent or temporary? Permanent? Sure? So that means a row ID, if it is a G, a row ID, if it is a M. Is it correct? Different mean yes or no? Anything you have to taking here, I'm not exactly taking, I'm taking anything else. Otherwise, I want to show you. Row ID concept, all of you remember? Okay, na? 3,000 H, G, H. Okay. 3,000 M. Now tell me, row IDs are different or same? Different. Okay. And yet each and every row is having unique row identification. This is already we discussed in which concept? Subqueries. Almost 1 week we spent on there. Okay. Now, and here, these row IDs, whatever it was there here, these row IDs are, it will be working just like a, what now? Page numbers. Just like a page number. So how your index page is there? In index page, every concept and page number, is there. If user will go to index page, I want to so-and-so concept, and the so-and-so concept is located on so-and-so page number. If I was know that, then can I directly jump? Or else are you searching page number 1, 2, 3? What are you doing? Directly jump. Same as here also. Understand na? Here how many 3,000s? 2. That means 2 3,000s are having in 2 different page numbers in my textbook. Concept clear? So now based on that, 3,000 is the second highest na? Compare here. Right side or left side? Right side. Because what I said, greater than or equals to. When your value, which is greater than or equals to root, then which side? Right side. Okay. Then I will come to right side. Right side already parent is there. Now parent compare. Left side or right side? Left side. Because 3,000 is a less than 5,000, greater than 5,000. Less than. So where it will store? Where it will store? Left side. 3000 will come left side. But how many rows? 2 rows. Then I'm giving 2 asterisk symbols. And here, what is asterisk, sir, representing means here? Here, asterisk symbol is nothing but row ID. Its asterisk symbol is nothing but what now? Row ID. It represented by your system like this. Okay, now? And now, this is called as a child level. This is called as which level? Child. So, root, parent, child. I can keep it this. Next one. What is my next biggest value? 2975. 2975 compare with this left side. Okay. In the left side LP, which is less than to 2975. Okay, which is less than to 2975. Then it will keeping under right side, and more than that keeping under left side. Okay, that's over. Parent is over. Next biggest value 2850. 2850. Compare here. Compare here. Left side. 2850. How many times? 1 time in my table. So 1 asterisk symbol. Next, what is the next one? 2450. Compare here. Compare here. Left side. 2450. 1 asterisk, huh? Yes. Next. What is the next biggest value? 1600, huh? 1600. Compare here. Compare here. Left side. How many? 1, comma. Okay, next. What is your next biggest value? 1500. How many times? 1 time. 1500. Compare here. Compare here. Left side. So left side here I won't write, but space is not there. I will give comma. Next line I'm writing. Okay, na? No problem, na? Don't confuse here. So 1500. 1 asterisk symbol. Comma. Next value. What is the next biggest? 1300. 1300 also there, na? 1300 how many times? 1 time. Can I keep this? Next. What is the next biggest value? 1250 how many times? 2 times. How many asterisks? 2 asterisk symbols. Next. What is the next biggest value? 1100, how many times? 1 time. So 1100. 1 asterisk symbol. Next. What is the next biggest value? 950. How many times? 1 time. 1 asterisk symbol. Comma. Next. What is the next one? 800. How many times? 1 time. So this is binary tree structure. Based on your root, it will start and arranging your data. The root value less than values are root less than values are left side. Root greater than or equals to values are right side. This is binary tree structure nature. Okay, how the values can be stored. Okay, after storing this, okay, that means the B tree index page is successfully arranged and created. After B tree index page is created, then the request is sending to server. Index is already there. You can go. Now server will come to this index, comparing your condition. What is our condition? Where salary is equals to 3000. First, it will be comparing at a root level. But in root level, your parent data was not stored. Parent level data not store. Where data storing? Child levels. That is a rule of binary tree. Okay. So now here, checking here, 3000 is equals to 3000. Condition, comparing and equal. Equal means which side it will go? Right side. That right side will come. Parent is there. Parent is there. So now again, this condition is checking with whom? Parent. When you're checking with the parent, left side or right side? Left side. Left side, yes, your original data is there here. Your data, what that means? Child row, child level. In child level, data will be stored here. And now 3000 is there. 3000 is having in the row ID number. What is this? H. 3000 is having in the row ID number. What is that? M. M. This is numbers. Got it? Now, when server first row ID, first 3000 ID number, how much? H. That means directly it will go to your table where? H only. But in my table, A, B, C, D, E, F, G. Searching or not searching? Not searching. Directly going to H only. H after going to H, pick the row, sending client. Again, next one is what now? M. Directly it will go to M. That means H after I, J, K, L, L not searching. So next directly going to where? M. M is directly going to. So M, H, got it. Then you just come back here. So come back here. So what happened? As per your binary tree structure data format, directly it will go to H and pick the row. After H, directly jump to M and pick up the row. It means that this row not such, not such, not such, not such, not such, not such, not such. This row not such, not such, not such, not such. This row not such. Then how many rows? Minus 2 is equals to 12 rows. 12 rows searching or not searching? Not searching. As what I said logically, each row will take 1 second of time to searching purpose. Now, how many seconds of time is saved? 12 seconds of time is saved. Because 12 rows are not searching means 12 seconds of time is saving. That means remaining how many are there? 2. That means your 2 rows retrieval out of 14 rows from your table within how many seconds? Within 2 seconds, your required data will be picked out of 14 rows. But table scan, 14 seconds. Index scan, 2 seconds. Now tell me which method you will be follow. Index only, na? Because it is the shortest time period, na? Shortest time period, my data will come. There, 14 seconds, same data will come. But here, 2 seconds, same data will come. So that means how much difference? 14 and 2, how much difference? 12 seconds. That 12 seconds of time is saving. That's called as a searching time is reduces and improving your performance is high. Now performance good na? Fast na? Your data accessing fast or slower? Very fast. This is what we called as a B-tree index advantages. That's why in real time on big data tables, especially your table is having 5 rows, 10 rows, not necessary. But small data, people will not apply indexes. When it was applied, When your table is having 100 rows or 1 lakh rows or 2 lakhs rows, at that moment, compulsory indexes are very, very important. If you're not applied indexes on lakhs of rows in a table, then your retrieval time is very, very huge amount of time it will take. That's why the indexes will be applying on big data tables to reduce searching time purpose, quickly accessing purpose, performance wise also, it will give good performance. This is the main intention, purpose, cause of your indexes. Clear all of you now? Right. Below right now. So now take this simple index definition, syntax, and syntax below example. Completed. Okay, right. So this is simple index, and the B tree indexes are how to arranging your data, and this is common mechanism for any type of index. Okay, na? Sorry, any type of index means these are simple, composite, unique, function, because these are all comes under B tree. Okay, so same way data can be arranged as per your given conditional value basis. Okay, no? Right. And simple remaining composite, unique, that all we discuss. And tomorrow you don't have a class. Okay, day after tomorrow. Okay, no? So again your class day after tomorrow. Tomorrow no class. Okay, no? Right, guys. Online student, tomorrow no class, and next class day after tomorrow. Okay, right. Thank you so much.
వాల్యూస్ ని అంటే ఇలా తీసుకోవాలా లేకుంటే ఈ కండిషన్ అంటే సాల్ ఈక్వల్ టు
ముందు డేటా అరేంజ్ చేస్తారు. ముందు B3లో 3 ఫార్మాట్ లో నీవు ఇచ్చిన వాల్యూ కండిషన్ బేసిస్ చేసి డేటాని ఫస్ట్ ఏది చిన్నది ఏది పెద్దది కంపేర్ చేసుకుంటే ఇలా అరేంజ్ చేస్తాం. ఇలా అరేంజ్ చేసిన తర్వాత అప్పుడు సర్వర్ అనేవాడు దీని మీదకి వచ్చి పర్ఫామ్ చేస్తాం. ఎప్పుడు ఆఫ్టర్ అరేంజ్మెంట్ అయిన తర్వాత